All right, interactions of waves. The fall of Galloping Gertie. My breath was coming in gasps, my knees were raw and bleeding, my hands bruised and swollen. Safely back at the toll plaza, I saw the bridge in its final collapse and saw my car plunge into the Narrows. This dramatic piece of writing is a witness's real-life account of the collapse of the Tacoma Narrows Bridge in Tacoma, Washington on November 7, 1940. Prior to its collapse, the suspension bridge was known for its swaying and rolling in the wind. This motion happened so regularly that the bridge was named Galloping Gertie. Only 4 months after its construction, the bridge collapsed into the waters of Puget Sound during a windstorm. Although a disaster, Galloping Gertie's collapse became a valuable teaching tool for engineers. All right, so why is Galloping Gertie an appropriate nickname for the bridge? If you were an engineer studying this bridge collapse, what is one thing you would research? Okay, what changes the direction of a wave? If you toss a ball against a wall, the ball bounces back in a new direction. Like a ball, waves can also change direction. Waves change directions by reflection, refraction, and diffraction. So reflection. When a wave hits a surface, any part of the wave that cannot pass through the surface bounces back. This interaction with the surface is called reflection. Reflection happens often in your everyday life. When you looked in your mirror this morning, you used reflected light to see yourself. The echo you hear when you shout in an empty gym is also a reflection. In Figure 1, you can see how light waves are reflected. All reflected waves obey the law of reflection. Okay, so Figure 1 here. The law of reflection states that the angle of incidence equals the angle of reflection. So, read the sequence of steps matching each step to its letter in the photo. If the angle of incidence is 45 degrees, explain what the angle of reflection would be. Okay? Refraction. Have you ever ridden a skateboard and gone off the sidewalk onto the grass? If so, you know it's hard to keep moving in a straight line. The front wheel on the side moving onto the grass slows down. The front wheel still on the sidewalk continues to move fast. The difference in the speeds of two front wheels causes the skateboard to change direction. Like a skateboard that changes direction, changes in speed can cause waves to change direction. So look at Figure 2. When a wave enters a new medium at an angle, one side of the wave changes speed before the other side. This causes the wave to bend. Bending occurs because different parts of the wave travel at different speeds. Refraction is the bending of waves due to a change in speed. Waves do not always bend when entering a new medium. No bending occurs if a wave enters a new medium at a right angle. Bending does not occur if the speed of the wave in the new medium is the same as the speed of the wave in the old medium. Okay, so looking at this figure down here. Light bends when it enters water at an angle because the side of the wave that enters the water first slows down before the other side does. So suppose you shine a light into a corner of an empty pool. Why will a different spot be lit up if the pool is filled with water? All right, diffraction. Waves sometimes bend around barriers or pass through openings. When a wave moves around a barrier or through an opening in a barrier, it bends and spreads out. These wave interactions are called diffraction. Two examples of diffraction are shown in Figure 3. All right, the waves bend around the barrier of the rocks, and then here the waves spread out after passing through the narrow opening. Okay, they pass through here and then they spread out into this bigger area. Okay. Use the 3 pictures on the right to answer the questions. Under each picture, write how the waves are changing direction. So in each of these pictures, here is a straw going into a glass of water, a boy standing in front of a mirror, and then that looks to be like 2 magnets near each other. In what way are reflection, refraction, and diffraction similar? Okay, so then down here under assess your understanding. What is diffraction And then classify. A wave bends after entering a new medium. What type of interaction is this? Alright, did you know? Interference is responsible for the iridescent color seen in oil films, soap bubbles, and the feathers of some birds, like the common grackle. The structure of the bird's feathers creates the interference. The bright colors are only seen at specific angles of reflection. Okay. What are the two types of wave interference? Have you ever seen soccer balls collide? The balls bounce off each other because they cannot be in the same place at the same time. Surprisingly, this is not true of waves. Unlike two balls, two waves can overlap when they meet. Interference is the interaction between waves that meet. There are two types of interference, constructive and destructive. So constructive interference in which waves combine to form a wave with a larger amplitude than any individual wave's amplitude is called constructive interference. You can think of constructive interference as waves helping each other or adding their energies. For example, in Figure 4, when the crests of two waves overlap, they make a higher crest. If two troughs overlap, they make a deeper trough. In both cases, the amplitude of the combined crest or trough increases. Okay? So, constructive interference. Explain what the black dotted line represents. Then tell what happens to the direction of each wave when the waves meet. So in the first one, two waves approach each other. The wave on the left has a greater amplitude. The crest's new amplitude is the sum of the amplitude of the original crest. The waves continue on as if they have not met when they're going opposite. All right, destructive interference. Interference in which two waves combine to form a wave with a smaller amplitude than either original wave had is called destructive interference. Destructive interference can occur when the crest of one wave overlaps the trough of another wave. If the crest has a larger amplitude than the trough of the other wave, the crest wins and part of it remains. If the original trough had a larger amplitude than the crest of the other wave, the result is a trough. If a crest and trough have equal amplitudes, they will completely cancel as shown in Figure 5. Destructive interference is used in noise-canceling headphones to block out distracting noises in a listener's surrounding. Okay, so look at the pictures below. In the boxes, describe the steps of destructive interference. All right, how do standing waves form? If you tie a rope to a doorknob and shake the free end, waves will travel down the rope, reflect at the end, and come back. The reflected waves will meet the incoming waves and interference occurs. If the incoming wave and reflected wave have just the right frequency, they combine to form a wave that appears to stand still. This wave is called a standing wave. A standing wave is a wave that appears to stand in one place even though it is just two waves interfering as they pass through each other. Okay, nodes and antinodes. In a standing wave, destructive interference produces points with zero amplitude called nodes, as shown in Figure 6. The nodes are always evenly spaced along the wave. At points in the standing wave where constructive interference occurs, the amplitude is greater than zero. Points of maximum amplitude on a standing wave are called antinodes. The antinodes always occur halfway between two nodes. Okay? So, as the frequency of the standing wave increases, more nodes and antinodes are created. So I want you to identify, in the second box, label the nodes and antinodes. Okay, and then your challenge. In the third box, draw the next standing wave in the series and label its nodes and antinodes. Alright, resonance. Have you ever pushed a child on a swing? At first, the swing is difficult to push, but once it is going, you need only a gentle push to keep it going. This is because the swing has a natural frequency. Even small pushes that are in rhythm with the swing's natural frequency produce large increases in the swing's amplitude. Most objects have at least one natural frequency of vibration. Standing waves occur in an object when it vibrates at a natural frequency. If a nearby object vibrates at the same frequency, it can cause resonance. Resonance is an increase in the amplitude of a vibration that occurs when external vibrations match an object's natural frequency. The Tacoma Narrows Bridge, or Galloping Gertie, may have collapsed because of resonance. Storm winds are said to have resonated with the natural frequency of the bridge. This caused the amplitude of the bridge's sway to increase until the bridge collapsed. You can see the result of the collapse in Figure 7. All right, the power of resonance. Winds blew as fast as 67 kilometers per hour during the storm in which the Tacoma Narrows Bridge collapsed. What might engineers do differently when designing a new bridge for this location? Okay, assess your understanding. Describe what causes resonance to occur, and then what causes nodes to form in a standing wave. All right, earthquakes happen. Natural events such as earthquakes, volcanoes, or extreme weather can cause major catastrophes. Scientists and others have been studying such events for centuries. One goal of this study is to understand these events well enough to actually predict when they might occur. Although predicting most types of natural disasters is still limited, scientists have learned a lot about why and how these events occur. For example, scientists understand the events that cause earthquakes. Most earthquakes happen because the outer layer of Earth's crust is made up of tectonic plates that are constantly moving over the surface of Earth. As the plates shift and move, the edges of the plates, called plate boundaries, rub, push against, slide under, or pull away from one another. Even when two plates get stuck where the boundaries touch, the plates themselves continue to move. Eventually, these stuck boundaries will slip to relieve the stress. This results in an earthquake. Earthquakes can also be caused in some areas by molten magma under the Earth's surface pushing up on the thin crust above. The upward force from the magma below causes stress on the brittle crust. When portion of the crust shift upward, this stress can cause an earthquake. Knowing how earthquakes occur helps scientists to work on ways to predict future earthquakes. This knowledge also helps engineers figure out better ways to make buildings that can withstand the forces of earthquakes. In addition, knowledge of earthquakes helps people understand how to better prepare their property and homes in the case of this natural event. Although there has been good progress on each of these fronts, there is still so much more scientific knowledge yet to be gained before earthquakes can be predicted accurately. Okay, so do research on how engineers design buildings to withstand the forces of earthquakes. Also research on better ways to protect people from earthquakes. All right, here is review and assessment. So you're going to go through the review and assessment for each of the lessons we went through. So what are waves, properties of waves, and then interactions of waves.